So let's get started on Copilot foundations. What I want to get started with is that we need to understand how Copilot works basically, and that is what we need to what we need to understand. And if we want to understand how Copilot works, it makes sense to also understand where it comes from. So where it comes from actually is Microsoft's collaboration with this organization called OpenAI. We all know OpenAI because they are the company behind ChatGPT. If you look at ChatGPT as a product, then what you'll notice is that for us, the user, it is a generative AI solution. And generative AI means that we are talking about an AI solution that can generate stuff. It can create something for us. Now, ChatGPT is a chat generative AI solution. You may also have heard of other AI solutions, like, for example, DALL-E, which is also by OpenAI, which is able to generate photos or pictures for you. There is plenty of different AI solutions that can create stuff for you. Videos could be created via AI. Audio, like music, can now being created by AI. If AI can generate stuff, it is called generative AI. Now, first of all, we are going to look at ChatGPT. First of all, we'll be looking at Copilot. Later, we will be also going through Microsoft's Azure AI capability. So these 4 hours that we are together here, we are going to talk a little bit about what Microsoft does in the AI area. And we are going to start by working with Copilot, and we are going to start by understanding Copilot a little bit better. So ChatGPT is actually one of the foundational components of Microsoft Copilot. If you look at how this works, is that basically what happens is that at OpenAI, there is people. Let's say this has to represent a person. Look at that. There are happy people, I guess. And these people have been feeding information into a data set. So basically what has been done at Copilot is that we have been feeding pretty much all kinds of data that is available on the public internet. So, for example, we can see speeches by famous people. We can see documents that were shared online. You can think about books. You can think about lyrics from songs. You can think about poems. You can think about like science-based documents and way more and more and more and more. We just have been feeding all these little pieces of information into a data set. And then the next step, if you have all these pieces of information in the data set, the next step is that we are going to train the model. You're going to train a model, and basically this means that it requires some time and it requires a lot of, let's say, compute power. And nowadays, if we think about compute, well, in the early days, we always were thinking about CPU. What we have noticed is that for training models, GPUs are more sufficient. The major difference between a CPU and a GPU is that a CPU has to work in the order of how data is being delivered to the CPU. It can do this very, very fast. GPUs are in general slower processing units. However, they come with many, and they can handle a lot of different calculations at the same time because they have so many cores. However, in the era of AI, we also see new kind of processing units. There is, for example, neural processing units, which would be interesting for us to also work with neural language. There is language processing units as well, LPUs. So pretty much what we are getting into is some kind of a new acronym that I made up, the XPU, or the any processing unit. Doesn't matter as long as it's able to train the model. When we train the model, basically what happens is that all these pieces of information are going to be connected in one way or another. So we are going to create relationships between the pieces of information without us really understanding what the reason is that data is being connected. However, we are seeing that we can see all of those different connections created between the pieces of information. And the result is that we, so down the line, so down the time that we are doing this, we are doing some tests like, hey, is the model trained all right at this point? No, then we do another test a little bit later, and another test a little bit later, yet another test. And at one point we think, hey, we give the model instructions, prompts, and those, when the model is good enough, so if we think, hey, this model is now capable of doing all the work that we expect from the model, then we are going to finish it. And that is when we create something called a large language model. The large meaning because there is a lot of data in there. The language model means, hey, there is data in that we can connect with our natural language. So it's a large language model. There is also something that is called a small language model, SLMs. Small language models are language models based on little less data. Oh, by the way, many people, they think when they look at pictures like these that this looks like that it looks like a human brain, and well, that is why this is also very often referred to as a neural network. The neural network is it acts like a brain, right? And actually, you could think about a large language model as if it is a brain. The brain has been trained, like your brain also has been trained. Your brain has been trained from the second you were born until this very second. Your brain has been seeing and hearing things. It has been experiencing things. It has been feeling things. It has been learning in school, for example. It has been learning by the mistakes that you make. And all of those things make the brain that is your brain up till this very, very second. A large language model is an artificial brain. And what we can do with this is we can connect to the large language model being a user. So here we could be the ChatGPT user, being the user here, and we can send into the large language model, we can send prompts. Now, I checked the results here. I can see that if people in this training, 17% of people do close to half of their work with AI. 62% not too much. Nobody is doing really a lot with AI, but some people do more than half. So what we do see is that many of you already know AI, and you may know ChatGPT for that, right? Now, if you look at ChatGPT, then this user can send prompts into ChatGPT. You can just send a message. You could say, hey, can you please explain the history of Microsoft to me, right? We can do a very quick and easy prompt, and this will go and create the responses. Basically, what's happening is that the LLM has all this information in it, all the data is in there. It will then look at my prompt. It will try to understand what I mean with this. There has to be some mechanism, which we'll talk about later. There has to be some mechanism that is able to interpret human language and then translate this into something meaningful meaningful into and then put that into the LLM, and it will then, it will look up the information and it will create a response, and it is generative AI. It is text, because it's chat, and this is the response. So here we see the history of Microsoft explained, in this case, with some kind of a timeline here. Now, that is one thing. But now we can also change this a little bit. We could, for example, say, explain this to me as if I could go into two directions. I can sort of be very polite in things, or I could be myself and have some fun, as if you, the chatbot, if you are Donald Trump. So how would Donald Trump explain Microsoft to us? Well, and then we can go and we can see that based on things that have absolutely nothing to do with Microsoft, is now intertwined with Microsoft, and we are creating the response here. So here we can see the typical way of Donald Trump communicating. All right, folks, listen up. This is going to be tremendous, absolutely tremendous. That is so. This actually works. So how does this work? Well, there is some relationship between maybe a couple of speeches by Donald Trump and the history facts of Microsoft. And now we're going to get everything together, and that will now bring back the response that we may like at this point. Make computing great again. It even sort of ends with a slogan. So that is how ChatGPT is able to combine pieces of information into a response. Now, the downside about ChatGPT is that, at one point in time, we have to decide that the LLM is done, that the LLM is finished. So I can actually ask questions to, let's open up a new chat, basically forgetting everything I ever entered earlier. And I can ask questions, for example, like, to what date have you been trained? Meaning, at what date did somebody say, hey, now this LLM is finished? And as you can see, the ChatGPT has been trained until June 2024. Maybe if we, for example, select a newer model, let's say if I would say the O1 model here, and I would ask this again, like, to what date have you been trained? Then, and let's be nice with a question mark, then I might get a different answer. Also, what we see is that we can see we get some timelines here, something with 2023, 2022. So we do see a couple of different values here. So the training and the point in time that we decide that this is all right, well, that is when the knowledge of the environment ends. Now, one of the things... Yes?
Question from Ferdinand Veenstra. How does public internet fit into the dataset? Is it dynamic looked up at the chat requests, or other way of working?
Well, the public internet itself, like with all we only need to focus in this case about on text, right? That is important. So we are not going to add in videos, but only the transcription of videos. We are not going to put in pictures, but maybe there is some kind of a note behind the picture that says, hey, what is this picture about? The text is relatively very, very small. So for that model, we are able to put a lot of data in. So it's not that we have to put the entire the entire internet in one data center. That's not what's happening. We take the text behind things. We take the lyrics of songs, not the actual music, right? That is a difference when it comes into data sizes. So hopefully that makes sense. When we add the prompts in, basically what we do if we don't do anything fancy, the LLM will only be able to respond based on what it already knows, right? What we have been feeding into the data, into that LLM while we were creating it. The interesting thing is that this brain, like all of your brains who are joining us in this session, all your brains, they do have some, let's say, common knowledge. For example, what happened on September 11, 2001. Then almost all of you will know this. Maybe that one person, the one person here that filled in that the age was, what was it? Between 18 and 25. You may not remember that, but all the other ones, they will probably remember this. That is common knowledge. But this brain is also able to answer questions about things that it has not been trained on. You could question why or how. Well, it is based on maybe that we can add some extra context into the conversation. So, for example, if I am creating a document, then I can ask Copilot about, hey, can you summarize, for example, this document for me? Now, the problem only is I can ask this. So let me just go back to GPT-4 for this example. This is responds a little bit faster, therefore. So I can say, can you summarize my document, right? Then Copilot doesn't know what document, so it will never be able to summarize my document that Copilot doesn't know about. But if I paste it in, right, then we can feed that document also into the LLM, then have ChatGPT summarize this document and give me the response back. But we do need some extra context in there. Or if I ask questions about, hey, what do I need to focus on today to be prepared for next week? Then also ChatGPT has no clue about my week, because my week is private data that is not public data. So unless I feed it into the system, ChatGPT will never be able to answer my questions. Sometimes it needs extras. Now, if for some cases, so basically what we can do, that extra context, we refer to as something called RAG, or this is short for retrieval. Retrieval, is it retrieval? Retrieval augmented, I sometimes, augmented generation, meaning we are feeding extra data into the prompt so the brain can answer the questions. So, for example, if I would ask you, oh, Frank, you're raising your hand.
Yeah, ik dacht, ik doe I do nice and raising my hand for a question.
Mm-hmm. All right.
A question received. ChatGPT can hallucinate. Can you explain how that works?
Yes, I will in a little bit. I will talk about hallucination. Yes. So the retrieval augmented generation first is the extra context that we can give into the system. Like, for example, I could upload let's say an output of my full calendar for next week, and then we can have that brain look at it, and it may be able to help me. So that is what we see here. So that is the retrieval augmented generation. Gives us extra context. For example, if I would ask ChatGPT about what I need to do with this fight that I had this morning with my girlfriend, for example, then ChatGPT doesn't know about the fight. But if I explain to it what happened, like if I would explain to you what happened, you would be able to give me a response based on how your brain is trained. Now, all the human brains, all the human intelligence will give me different answers, because all brains have been trained differently, right? That makes sense. This brain is just one of the many, many brains. There is, as we will see later, many large language models or many AI models that have been created by different people based on different data, based on different ways of learning. And that means that we have more than one brain that would give me different answers for the prompts that I sent. Hallucination is that what we always have to remember with a large language model or with AI, it is artificial intelligence, meaning it is not actual intelligence. ChatGPT is a component that is ChatGPT is a component that is it's a computer, but it's not actual intelligence. GPT is actually short for a generative pre-trained transformer, and the transforming part of this is that it will basically go in, and it is a very, very fancy and a very, very advanced, but nothing more than a next word prediction tool. So there is not actually somebody thinking about something to give you an answer. It's a system that is based on the context that it gets. It will go and create output based on next word prediction model. A next word prediction model is also something you have in your phone. For example, when you are writing a chat message or via WhatsApp or messages or something, it will already give you a couple of options of what the probability is that your next word will be. Well, ChatGPT is like that, but very, very fancy, and it comes with really nice interactions, but it's not an actual intelligence. So one of the problems with computer-based or artificial intelligence is that it is not very good in checking its own output. So we, human brains, we have a gut feeling. Computers do not have a gut feeling. So sometimes the model could be wrong, right? It could sort of make up things, what we call hallucination. It will make up things because that is what it thinks would be the next right word in this line of text. So you could question how valuable is all of this? Well, the good thing is that ChatGPT and also Copilot are right for, let's say, 99% of the time, maybe even more than that. So it can still take a lot of your work away from you in order for you at least to speed up your work. But it will not be, you cannot just leave Copilot or ChatGPT to itself and handle everything by itself. That's why Microsoft actually deliberately named Copilot. You are the pilot. Copilot is nothing more than your assistant, your Copilot, and you will always have to check on what it creates. It will still save you hours and hours and hours per month, but you are going to be the person creating it using AI tools. That is where hallucination comes from. Well, by the way, this is all ChatGPT. Let's look at what happens if we switch now. If we make the switch to what happens at Microsoft. So